Let's look at some of the basic components of algebra. We're going to look at a variable first. A variable is an unspecified value often represented by using a letter or symbol. What does that mean? I'm going to use the example that I'm a car salesman and I make, let's say, $30 an hour. But every time I sell a car, I get a commission on that sale. So let's say a commission is right here. That commission, which I have labeled here as COM, is going to be our variable. It's a symbol here. It's using letters. And it's going to vary depending on if I sell a car or not. So a variable is a varying amount. It's going to be different depending on the cars that I sell. So let's say I make $30 an hour and I sell a car and get a commission of 100. That commission can be translated to $100. So that hour I made 30 plus commission, which would be 30 plus 100. I made $130 that hour. Now, typically you don't see a variable as a bunch of letters like COM for commission. Typically you would see 30 plus C, which would be commission. So they usually use one letter instead of a bunch. So our expression that we could use to show how much money I can make in an hour could be 30 plus C. And then depending on what kind of car I sell or how much my commission is, that C is going to change. It's variable. It can change depending on the car we sell. Let's keep using our commission example for an expression as well. If we have 5C and we don't know how much that C is worth, it's called a monomial. We don't know the value of C, so we're just going to treat it like it's 1. We have 5C. If I wanted to add 5C to 3C, which is another monomial, we can get 8C because these are like terms. They're all related with that letter C. If we have 5C plus 3, we can't do anything. We can't add 5C to 3. So our expression is done. We can't do anything else. We have to keep it as 5C plus 3. If we have something a little bit more complicated, like 3C plus 27C subtract 5, we can still solve this. It's not done because we have like variables. The C's, we can add 3C plus 27C, which is going to give us 30C minus 5. Our expression is done there. We can't go any further. We can't subtract 5 from 3C. So what we're doing is taking an expression and we're simplifying it to 30C minus 5. We're taking our like terms and we're figuring out what the most simple version of that expression. And the definition that I have up at the top for an expression is a collection of symbols, including one or more variable and possibly numbers and operation symbols. Operational symbols are our addition, our subtraction, multiply, and divide. Those are operations. An equation is when we have two expressions and they're set with an equal sign. So if we have, let's do an easy one here, 4 plus 5 equals 6 plus something. We have our equal sign in the middle, and we have an expression here, 4 plus 5. We know that it's equal to the same size over here. 6 plus something is going to give us the equivalent. So 4 plus 5 we know is 9. 6 plus something that gives us 9 would be 3. Now we have an equal equation. If we had 10 times 4 is equal to 20 plus something. What could that something be? Let's solve the first part of our equation first. We have 10 times 4 is 40, and 20 plus what is going to give us 40? 20. So we know that 10 times 4 is equal to 20 plus 20, and both sides are equal to 40. If we look at our top example, 4 plus 5 equals 6 plus 3. The 4 plus 5 and the 6 plus 3 are both expressions where the whole thing, 4 plus 5 equals 6 plus 3, is the equation. In this second example, 10 times 4 is an expression, 20 plus 20 is an expression, but the whole thing is making up an equation. An equation can also be as simple as, what is 3 plus 4? As long as we have an equal sign, we're going to have an equation. When we don't have an equal sign, we can think of it as an expression.